Hello, this is Mr. Soy. Today we're going to be looking at basic equation solving. And this is something that is persistent throughout all of algebra. And today we're just going to look at linear equations because we're starting out slow, a little bit simpler. And then eventually by the end of the year in Algebra 1, you're going to be solving a little bit more complex, such as quadratic equations. But today we're just looking at very simple, basic linear equations. Well, the basic process for solving equations kind of runs down the following. So we have this idea of simplifying expressions. And what simplifying expressions is all about is, well, there's an order of operation that we have to take care of. You might know that as PEMDAS, and we'll look at that here in a second. Then there's distributive property. So oftentimes in PEMDAS we have P for parentheses. Oftentimes we need to get rid of the parentheses so that we can solve our equation. Well, the distributive property gives us a way of doing that. And then finally we like to combine like terms, and that all of those things right there are generally simplifying expressions. Then we typically want to be able to move terms in the equations, like from one side of the equal sign to the other side. And then the goal is always to isolate variables. In this case, the variable that we're looking for. So today we're going to be looking at solving the following: one-step equations, two-step equations, and then finally multi-step single variable equations. And single variable is important. Later we'll look at what happens when I have lots of variables in my equations and I'm just trying to solve for one, but today we're keeping it simple. All right. Well, we need a little bit of review of the order of operations, and what I've got here is I've spelled out PEMDAS. You can see it going down here, PEMDAS. And then I've essentially defined what each of those things means. You might also have heard it as, please excuse my dear Aunt Sally. And that's just a bit of a mnemonic device to maybe help you remember. But this tells us the order that basically operations have to occur in for us to have legal mathematical moves, especially when we're solving equations. Parentheses, well, parentheses, basically the idea behind parentheses is I've got something like the following: 2 times x minus 4 plus 1. And before I can get rid of those parentheses, I'm really trying to find out, hey, can I get rid of anything, or can I combine anything, or can I simplify anything inside the parentheses before I essentially am going to distribute the 2 through. And in fact, in here you can see, oh, wait a minute, I could take -4 and add a 1 to it, and I end up with -3. And we'll look at that. And that's the idea of parentheses. We want to try to get rid of or simplify as much as possible whatever we have inside the parentheses. Next one is exponents. And exponents are important because if I have something like the following: 2 times 4 squared, then exponent tells me that before I do the multiply, I have to do the exponent to the 4. In other words, I have to square 4 first before I do the multiply with the 2. And that's exponent right there. Next we have multiply, and everyone's pretty familiar with that. It's something like, 2 times 6. And we want to be able to do those before we ever do the other ones. In reality, we have a situation where essentially multiply and divide are really kind of at the same level, same with add and subtract. And so in those instances, we always want to basically do those operations from left to right. So if I have something like 2 times 6 divided by 3, then the divide and the multiply are kind of at the same level, so by convention we're basically going to go from left to right, so it'd be 2 times 6 first, giving me the 12, then divide that by 3, giving me the 4. And that's basically the idea behind that. And then we have add and subtract, same sort of situation where if I have essentially 4 minus 8 plus 6, then they're pretty much, add and subtract are pretty much at the same level, and so we're just going to go from left to right by convention. And so I'm going to take 4 and I'm going to subtract 8 from that first, giving me negative 4. Then I would add that to 6, giving me the positive 2. And that's basically the idea here, is that we're going to go from left to right on those. Okay, and that's basically PEMDAS. All right, well, let's take a look at a quick example and see how this might apply. So let's say I have the following here. Let's say I have 2 times 4 minus 3 squared minus 8 plus 6 times 2. And I'm asked to evaluate what that is. Well, I'm just going to simply go down through each of my operations and then perform them inside this expression. Notice it doesn't have an equal sign or anything like that, so this is an expression versus an equation. I'm going to start with parentheses, and inside my parentheses I can see I have 4 minus 3 squared. So now I start again. In my parentheses, do I have parentheses? No. Do I have exponents? Yes, I do. Right here I have a square of the 3. So the first thing I need to do is square the 3. And when I do that, I end up with 2 times 4. And the 3 is squaring that is actually going to be before the negative is multiplied to it. Therefore, the answer remains negative. So it's going to be 4 minus 9, because 3 times 3, 3 squared is 9. And then everything else basically stays the same for the moment. Now I've got to finish my parentheses because I got the square out. And the only thing left I can do here is the 4 minus 9. And so I'll take care of that, and I end up with 2 times negative 5 minus 8 plus 6 times 2. And now I have done my parentheses, my exponents, and parentheses completely. And so now I'm down to here where I want to multiply and or divide. Well, I only see multiply in there. There's no divide. And so I'm simply going to multiply all of the multiplications that are in there. 2 times this parentheses is the same as multiply. And then I have 6 times 2 here. I'm going to do both of those. So we get 2 times negative 5 gives me negative 10. Minus 8 doesn't change. And then plus 6 times 2, which is 12. And now I have completed both the multiplies here and here. And we're finally down to the very bottom here, add and subtract. And I've got both. I'm just going to start from the left and work my way to the right. And when I do that, I get negative 10 minus 8 would give me negative 18. And then plus the 12. And now I do that last step, which is the negative 18 plus 12, which would give me a negative 6. And I am done doing PEMDAS, or order of operations, for that particular expression. Okay, the next thing we need to do is we need to kind of review the distributive property. And the distributive property, as I have it written here, states that if I have A and then in parentheses B plus C, I can literally multiply the A times the B and then the A times the C and rewrite it without parentheses as AB plus AC. And that's the distributive property. And so we use that to help us get rid of parentheses. That's the basic idea here. Because we've got this multiply operation, but if I have terms inside that I can't simplify down to one term, then the distributive property allows me to take that number A and then multiply that to everything on the inside of the parentheses. So it's pretty straightforward. You know, if I had something like 2 times x squared minus 4x plus 6, then the distributive property basically tells me that I can take my 2 and I can simply multiply it to the x squared term, to the 4x term, and to the 6 term, and then write it without parentheses. I would end up with 2 times x squared, or 2x squared. 2 times negative 4x gives me negative 8x. And then 2 times 6 would give me the 12. And that's using the distributive property to essentially take this, which is this term multiplied to the entirety of the parentheses, and then I can write that out essentially without parentheses. So let's take a look at another example here real quick. All right, so let's say I have 4x times 6 minus 3x. Well, again, distributive property says I can take my 4x, multiply it to that first term, which is 6. Then I can take the 4x and multiply it to the second term, which is the negative 3x. When I do that, I end up with 24x, and then 4x times negative 3x would give me negative 12x squared. And now I have distributed the 4x through the parentheses to the 6 and the negative 3x to end up with this term here. And that's the basic distributive property. All right, continuing with our review that we're doing here of some of the skills that we need for equation solving, I want to talk a little bit about combining like terms. And as you can see here, we have this concept that like terms must have the same variable, and the variable must have same exponent. So let's just take a look here. If I have something like, let's say 2x and 3xy, then would these be considered like terms? Well, let's take a look. It says like terms must have same variable. Well, there's an x here, and then there's an x there, but there's also a y here, and there's no y there. Therefore, this is automatically not like term. These are not like terms. How about this one? What if we have x squared and 7x squared? All right, well, let's take a look at this one. Same thing. Do we have the same variable, x and x? Yes, we have the same variable. And there are no other variables besides x, so we're good there. Then the variable must have the same exponent. Let's take a look. I have a 2 here for my exponent, and I have a 2 there for my exponent. So these both have the same variable with the same exponent. So indeed, yes, these are like terms. Last one, let's say I have negative 4x and 9x cubed. Are these like terms? Well, again, let's take a look. I have an x here, I have an x there, so same variable. But when I look at my exponents, here I have an exponent of 1. We just normally don't write the 1 there, but there's a 1 there. And then here I have an exponent of 3. So it fails the second part, which is they must have the same exponent. So, in fact, no, they're not like terms. Okay. Well, the idea is if I have like terms, I want to be able to combine them. Combining them is really nothing more than adding or subtracting them together. Because in essence, I want to get down to a single variable at some point, right? That's at the very end of our equation solving process. Well, if I have all these different terms and they're like terms, well, I can't get down to a single variable until I combine all of those like terms. So let's do a quick example to kind of demonstrate what that looks like. So let's say I have the following. Let's say I have 7x squared minus 8x plus 6 minus 4x minus x squared plus 1. And so in this instance, I'm basically trying to find all of the like terms inside this expression so that I can combine them all together and I can simplify this expression. Well, the way that I do it when I'm looking at like terms in a large expression like this where I have various exponents is I simply underline the terms based on the power of the exponent. So I have a power of 2 here, so I'm going to underline that term twice. Now I move over to the negative 8x. That has a power of 1, so I underline once. Now I go to 6. Well, there's no variable with a power, so I don't underline at all. I just leave it. I go to negative 4x. Okay, again, power of 1, so I underline once. And now I move over to the negative x squared. Well, like the first term, that has power of 2, so I underline twice. And then finally, this last term, plus 1, again, doesn't have a variable with an exponent, therefore we don't underline it. Turns out it's really a power of 0, but we're going to cover that later in the course. For now, just know that if there's no variable, I don't underline it. Now, once I have that, I know what terms are like terms. I've got the same number of lines underneath the terms that I can combine. And I'm simply now going to combine them. I'm going to combine 7x squared, and I'm going to subtract the x squared from that. Because as you can see right here, they both are underlined twice. So these two are like terms. Likewise, I take my negative 8x and my negative 4x, and because both of those were underlined once, same variable, same power, I can combine these as well. And then finally, these last two terms, the plus 6 and the plus 1, those can also be combined to simplify the expression. So the idea is here, those are like terms, these are like terms, and these are like terms. And now I can simply combine those to simplify my expression. I'm just using the parentheses there to illustrate which ones are being combined. And now I combine them. 7x squared minus x squared gives me 6x squared. Negative 8x negative 8x minus 4x is going to give me negative 12x. And then finally, positive 6 plus 1 gives me positive 7. And we are done. We've simplified our expression from the much larger one up above to this simpler form down here simply by combining like terms. And that's the process that we're going to use when we're trying to gather all of our terms, variable terms, move them on one side, gather them together, and eventually isolate the term, the variable by itself, so that we can solve the equation. All right, so that leads us to this idea that I want to be able to move terms in an equation. When I have an equation, and I'm just going to write one up here real quick. When I have an equation like the following, 4x minus 3 equal 6x plus 1. Notice here that I've got x's on both sides of the equal sign. And at some point, I'm going to need to get those all on one side. To do that, I need to know how to move terms in an equation. Well, it turns out we have a rule for that, and the rule is really simple. It says whatever you do to one side of the equation, you must do to the other side of the equation. So over on this first side, if I want to move the negative 3 over, I have to essentially get rid of it on this side. The easiest way to move something or to get rid of it on one side is to essentially do the opposite operation. Notice it's a negative 3, and so to move it, I want to add 3, because when I add 3 on this side of the equation, these two terms cancel, because negative 3 plus 3 is 0. Thus, on this side, I'd be left with 4x. Now, on the other side, well, I added 3 on the first side, and to follow our rule, I have to do the exact same thing on the other side. Otherwise, we simply do not have a valid operation. This is how we move from one side to the other. And notice that when I do that, I end up with 1 plus 3, which is 4. And essentially what I did was I moved this negative 3 to the other side of the equation by doing the opposite operation. It was negative, so I simply added or made it positive. It canceled on this side, moved it to the other side where I combined it, and I ended up with this. That's how we move terms in an equation. Now let me show you an example, and in the example I'm going to move one of the variable terms. Alright, so let's say I have the following. 3x minus 6 is equal to 9x plus 8. And what I want to do is I want to essentially move one of the x's to the other side. It turns out it's one of the steps in our equation process where we're trying to essentially move the variable terms all on one side so that we only have them on one side. Well, it doesn't matter which one you move here. I'm going to move the 3x over to the other side with the 9x. And again, I just follow the rules that I know, which says if I want to move a positive 3x, I'm going to have to subtract 3x from this side. And as long as I do it on the other side, it's okay. That's our rule. Whatever I do on one side, got to do it on the other side. Now, these terms here cancel to 0, and I'm left with negative 6. And it's been moved to the other side, and now I just combine the 9 and the negative 3x, and I end up with 6x plus 8. And what I've done there is I've simply moved the negative 3x to the other side of the equation. And we're going to use that in our processes for solving equations, where we're trying to collect our variable terms all on one side. Okay, our last really piece that we need to understand is this idea of isolating the variable. What does that mean, isolating the variable? And I've written it here so you can kind of read through it, but the basic idea is we want the variable on one side of the equation and everything else on the other side. That would isolate the variable all by itself, thus giving us the solution to the equation. And we do that by simply moving everything to the other side and moving our variable term to the opposite side. And I'm just going to show you here real quick, all right? Understand that we're going to do more of these, but I just want to kind of give you an idea. So if I had the following, let's say I have negative 2x plus 1 equals 6. Then the idea is I want to get x all by itself. I want to isolate the variable. In this case, our variable is x. That means I have to move whatever is with the x to the other side. I've got to move my plus 1 over, and I also have to move this negative 2 over. When I do that, I will have solved the equation. Kind of the final step typically will be, getting rid of this coefficient in front of your variable. But let me just show you real quick, because we just talked about moving variable or terms around an equation. And so I'm going to do it really quickly here for these two items, the plus 1 and the negative 2. I'm going to start with my plus 1, and to move that I do the opposite, which is negative 1. And as long as I do it on the other side, I'm good to go. It cancels over here, and I'm simply left with negative 2x, because I've moved the positive 1 over by subtracting it. And on the other side, I get 6 minus 1, which is 5. And then finally, the last thing I need to do is I need to get rid of this negative 2 in front of my x. Well, again, I'm going to do the opposite operation. Now, you might say, oh, wait a minute. Well, the opposite operation is going to be plus because I have a negative 2 here. But look closely. You're actually multiplying the negative 2 to the x. And we want the opposite of what's happening to the variable. Well, if I'm multiplying to the variable, then the opposite has to be divide. And so I simply divide by negative 2. And as long as I do it on the other side of the equation, like our rule states, I'm going to be good. On this side, well, negative 2 divided by negative 2 gives me 1x. Well, I can just simply write that as x. And then on the other side, well, I can do that division if I want. That would give me a negative 2.5 when I divide 5 by negative 2. And that's the idea of isolating the variable. We want to get everything to the other side so that all we're left with is a variable on one side and everything else on the other side. All right, let me do one more example, show you that. So let's say I have negative 4x minus 1 equals 9. Okay, well, I'm going to move the negative 1 and the negative 4 to the other side. That would isolate my variable x by itself. I'm going to start with the negative 1, and the opposite of minus 1 is plus 1. And again, as long as I do it on both sides, I'm good to go. Cancels on this side becomes 0. I'm just left with my negative 4x. And then on the other side, I get 9 plus 1, which is 10. And then finally, I want to get rid of this negative 4. It's multiplying to my x. So the opposite to move it would be divide. So I'm going to divide negative 4 on this side. And as long as I do it on that side, I'm still good to go. Over here, negative 4 divided by itself, or negative 4, is 1. And I'm left with simply x. And then on the other side, I can simply simplify the fraction in this situation, where I can essentially take a 2 out of the top and bottom. And when I simplify that, I'll end up with a negative 5 halves. Turns out it's the exact same answer we had in the previous example I did. But that's the idea of isolating the variable, so that all I have left is the x on one side and then anything else on the other side. All right, next we're going to look at actually solving equations. We're going to start with simple one-step, then do a two-step, then look at a more complex model for solving multi-step equations. All right, we're going to start off with one-step equations. They are going to be the simplest equations that we can solve. Our goal here is simply to isolate the variable. So we just want to move whatever's with the variable to the other side, and we're good. Well, there's two possible cases here. I could have a number adding or subtracting from or to my variable. For example, I could have x minus 5 equals 6. This is a one-step equation. I would need to move the negative 5 over. Or I could have something like plus, which is x plus 2 equals 3. Again, I would need to move the plus 2 to the other side. Or I could be multiplying or dividing to my variable, which is more often the case in a lot of the equations we're going to be solving. Here I've got a 2 multiplying to my x. I need to move that 2 to the other side. And same thing over here, I have a 1/2. Well, that's essentially dividing by 2. So here it's x being divided by 2. So I'm going to have to move that divide by 2 over to the other side. Okay, and we always move by doing the opposite. So let's take a look at a couple examples of these. So the first one I'm going to look at is I'm going to have x minus 3 equals 7. And in this situation, I've got a negative 3 with my x, so it's minusing, subtracting. And so to do the opposite would be to add 3, and that would move it. And as long as I do it on the other side, I'm good to go. Well, negative 3 plus 3 is 0. And so I'm simply left with my x on this side. And then on the other side, I have 7 plus 3, which is 10. And we have now solved the equation. X is equal to 10. That's a one-step equation. I only did one thing. I moved the negative 3 over to the other side. Let's look at one more example, this time multiplying or dividing. So let's say I have something like 1/3 x equals 6. Okay, well here I've got 1/3 multiplying to the x. That's one way to think about it. Or x is being divided by 3. Either way, okay, if I'm multiplying by 1/3, then I would have to divide by 1/3. But if I look at it as, hey, this is really x divided by 3, then the simplest way is to multiply by 3, the opposite of divide. And so on this side, I'm going to simply multiply everything by 3. And as long as I do it on the other side, I'm good to go. Well, turns out that 3 times 1/3 is 1. Another way of thinking about it, and this is the way I was raised or taught, is that 3 up top, 3 on the bottom, those cancel to be 1, and I'm simply left with what is left, my x. Other side, 3 times 6, that's simply 18. And now I've had a one-step equation that I've solved, and I have my solution, x equals 18. And that's the basic idea behind one-step equations. Okay, now we're moving on to two-step equations. And the idea behind two-step equations is I'm going to move a term or combine like terms. So it kind of depends on the situation that we might have. And then finally, I isolate my variable by itself. And that's kind of the last step. One step, two-step. Okay, so here I've written some down. So here, this is a two-step because I would need to essentially move that plus 8 to the other side, and then finally isolate the x by getting rid of the 2. So I'm getting rid of the 8 and the 2. That's a two-step equation. Here, well, this is that second sort of case where I have a 3x and a negative x. Those are like terms, right? Same variable, same power. So I would combine these first, and then whatever the coefficient is after that, I would then need to get rid of that, and that would also be a two-step. So let's take a look at some examples of two-step equations. All right. Well, the easiest would be to simply just use those examples I have. So I've got 2x plus 8 equals 10. Step 1, I'm going to move this plus 8 to the other side, and to move it I do the opposite. Well, opposite of plus 8 is minus 8. That turns it to 0 on this side, and I'm left with just 2x. And then on the other side, well, it's just 10 minus 8, or 2. Now, I've essentially moved the term over. Now I'm going to isolate the variable. And to isolate the variable, well, remember, it's 2 times x, so to do the opposite would be divide by the 2. And so I divide the 2 here. And again, as long as I do it on the other side, I'm good to go. Over here, 2 divided by 2 gives me a 1x. but we never write the 1 in front of the x, so it's just x. And then 2 divided by 2 gives me 1. And we are done. We've got the solution, x equals 1. All right, now we're going to do this other one over here. 3x minus x equals 6. Well, again, my first step now is I'm going to combine like terms. Because notice I've got an x and an x, power of 1 for both. These are like terms, I can combine them. So I'm going to do that first. And when I combine 3x minus x, I end up with 2x equals 6. So step 1, we've completed. We essentially combine like terms. Now we're going to do our step 2, which is isolate my variable. I have a 2 times x, so I'm going to, again, do the opposite of multiply, which is divide. And as long as I do it on both sides, I'm good to go. And once again, 2 divided by 2 gives me the 1. So all I have left is x on this side. And on the other side, I have 6 divided by 2, which is 3. And now I have my solution, x equals 3. So those are two great examples of two-step equations. And you need to know how to do those, and you will get practice. And that leads us into essentially multi-step equations. Now we're looking at something that's a bit more complex. Now again, we're only focused on linear equations at the moment. So very simple linear equations. And this 4-step process that I've written here is actually a really good process to follow to be able to solve multi-step equations that are linear. So let's take a look at each step. Well, first, we're going to simplify each side of the equation. So that means on the left side of the equal sign, I'm going to simplify. I'm going to do order of operations. I'm going to distribute if I have parentheses to get rid of. And then finally, I'm going to combine all the like terms that I have. That's simplifying that side of the equal sign. Then I'll go to the other side of the equal sign and I'll do the exact same thing. I'll take care of any order of operations that I need to. I will use the distributive property if there's parentheses, and then finally I would combine any like terms that I would have. After that's completed, then we move to step 2, which says, hey, get the variable term on one side of the equation. Okay, so a variable term would be something like 3x, negative 8x, 4x. That's a variable term. Could have a coefficient and a variable. So what we want to do is we want to make sure that any variable term we have in our equation, that we move them all to one side of the equation. After that, we're then going to isolate that variable term. Because once we move it over, we're going to combine it with whatever like terms are already there. So now we want to isolate what's left, the variable term that's left. So we want to move everything else to the other side. And then finally, that last step, which we are kind of getting used to now, which is isolate the variable. We just want to get anything that's left with the variable moved to the other side. All right, let's go through this step by step with an example, and I think this will make a lot of sense to you. All right, so here's step 1, and we've got our example. Our example is 3 times the quantity x minus 2 plus 8 is equal to 10 minus x. And we want to solve this for our variable x. Step 1 says, okay, simplify each side of the equation. So I'm going to start with my left side. And looking at my order of operation, I notice that inside my parentheses, p, I can start there. And inside I have x minus 2. They're not like terms, so I can't combine those at all. There's no exponents. So essentially I'm done. There's no order of operation that I can complete on either side of the equation at this point. Now I'm going to look at, okay, well, distributive property. Do I have parentheses I need to get rid of? I do. I have the parentheses right here. I want to get rid of those. So I'm going to distribute my 3 through the parentheses. And when I do that, I end up with the following. 3x minus 6 plus 8, and then there's no parentheses on the other side, so I'm done there. And now I'm going to do any add, subtracts, multiply, divides that I have. Well, Notice here I really only have what's left are these two like terms which I can combine, and that's part of the last part of simplifying, combine like terms. I have a -6, a +8, I can combine those, and when I do that, I end up with this side being 3x plus 2 is equal to 10 minus x. And I have now simplified both sides of the equation. That's all step 1. Now I move to step 2. All right, so I've got step 2 written out here after what we did on the last page. And step 2 says, get variable term on one side of the equation. Well, I've got an x here, that's a variable term, and I have a 3x here, that's a variable term. I want to combine these two on one side of the equation. Well, by convention, we generally try to move everything to the left side of the equation because we read left to right, and for a lot of people it's comfortable saying, okay, well at the very end x is equal to something. So we generally try to get it on the left side, but you can move it to the right side if you want to as well. But because I'm going to follow our convention, I'm going to move -x to the other side. And remember, how we move is the opposite. Since it's a -x, I'm going to add x on this side. When I do that, I end up with those two canceling, and I'm simply left with 10 on that side. Now, I have to make sure that I do the exact same thing on the other side of the equation, otherwise we're breaking our rule. So I'm going to add x on the left side of the equation. I get 3x plus x, which gives me 4x, and then my plus 2 just comes on down. That's step 2. Notice I started with variable term here, variable term here. When I'm done, I now have only one variable term on one side of the equation. I have completed step 2. That brings us to step 3, which tells us we isolate the variable term. So now this is the variable term, 4x. So anything with the 4x, I got to get rid of. Turns out the plus 2's there, so I'm going to move that to the other side. Doing like we normally do, I do the opposite operation, so it's going to be subtract 2, and as long as I do it on both sides, I haven't broken my rule. So over here, that cancels, gives me 0 plus 4x, or simply 4x. And on the other side, 10 minus 2 gives me an 8. And we have now completed step 3. We've isolated the variable term. The variable term's 4x. It's now by itself on the left side of the equation. Bringing us to our last step, perhaps the easiest step for some people, which is number 4, isolate the variable. I've got my variable right here, x. I want it by itself, so I have to get rid of whatever's with it. In this case, I have a 4 with it, so I need to get rid of the 4. The 4 is multiplying to my x, so the opposite operation to move it would be to divide. So I'm now going to divide this side by 4, and again, as long as I do it on both sides of the equation, I am good to go. On this side, 4 divided by 4 is simply 1. 1x gives me simply x. On the other side, 8 divided by 4 is 2, and we have now followed the 4-step process to solve the equation. And our equation solution is x is equal to 2. Now, once we're done, one of the best things to do is to go back to your original equation, plug in x equals 2 to make sure that it works. This is called testing your solution. So I'm going to write up here our original equation, which was 3 times the quantity x minus 2 plus 8 equals 10 minus x. And what I'm going to do is I'm going to substitute x equals 2 into this equation for the x's. So wherever I have an x, I'm going to put a 2. I have one there and there. I'm now going to replace them with my solution of 2. When I do that, I end up with 3 times the quantity, 2 minus 2. So I substituted in my x as a 2, plus 8 equals 10 minus 2. So again, I took the 2 here, which is equal to x, and I simply plugged it in for the 2 x's here and here. Now I follow my order of operation on each side of the equation so that I can get a final number. All right, well, inside the parentheses, 2 minus 2 gives me a 0. And so I'm now given 3, let's go with the black, times 0 plus 8 is equal to, well, 10 minus 2 gives me 8. Well, if I look closely here, I can see that anything times 0 is simply 0. So this entire part of the equation or expression right here turns to 0. 3 times 0 is 0. And I'm simply left with 8 equal 8, which is a true equality. Therefore, it checks out that my solution is correct. Well, we're going to finish up this lesson today by looking at some examples of each type. We've got a one-step, a two-step, and a multi-step equation. So it gives you a little bit more heads up on each of these types and how we solve them. So we'll go through each one in detail. All right, the first one, we have 1/3 x equals 7. What I have here is a one-step equation because I have my variable with simply one operation happening to it. It's a 1/3 times x, or I can think of it as x divided by 3. I want to get rid of that 1/3, so if I'm dividing by 3, the opposite would be to multiply by 3. So I'm simply going to multiply this side by 3, and as long as I do it on the other side, I'm good. 3 divided by 3, well, those cancel and give me 1. So now all I'm left with on this side is x. And then on the other side, 7 times 3 gives me 21. And I have solved that one-step equation. Next one up, we've got negative 2x minus 5 equals 9. This is a two-step equation. Two-step, where I'm subtracting a 5 first, then I have my negative 2 multiplying to the x. Up first, I'm going to move that negative 5 over by doing the opposite, which is add the 5. And again, as long as I do it on both sides of the equation, I'm good. Turns to 0 here, and so I'm simply left with negative 2x on this side. And then 9 plus 5 gives me 14 on the other side. And then the last thing I need to do is isolate my variable, x. I've got a negative 2 in front of it, multiplying. So to get rid of it, I'm going to divide. And so I will divide by negative 2 here. And again, as long as I do it on both sides of the equation, I'm good to go. Negative 2 divided by itself is simply 1, or 1x. And write it up over here. And on the other side of the equation, well, I have 14 divided by negative 2, which gives me negative 7. And we have also completed that equation. We've isolated the variable, and our solution is x equals negative 7. The last one on the bottom here, number 3, is a multi-step equation. And I'm going to follow that sort of 4-step model. The first step tells me that I need to simplify each side of the expression. So I'm going to start on my left side here. What can I do to simplify that? Order of operation. Well, I look in my parentheses here, and indeed I have two numbers that are like terms, x to the 1, x to the 1. I can combine these by adding them. So x plus 2x. Well, what happens when I add 2 more x's to the 1x I already have? I end up with 3x's. And on the other side, there's nothing I can do because those are not like terms. I cannot combine them. There's no other order of operations over there. And down here, almost done with the left side, I can now multiply these two together. Negative 5 times 3x is giving me negative 15x. And that is all step 1. And I am done with step 1. Now I'm going to do step 2, which says get my variable term on one side of the equation. I'm going to move my 3x over. To move my 3x, I'm going to subtract it. Again, we do the opposite operation. It's positive up there, so I'm going to subtract it to move it. And again, as long as I do it on both sides, I'm good to go. Over here, these cancel, and I'm left with simply negative 6 on that side. On the other side, on the left side, got negative 15x minus 3x. Well, that gives me negative 18x when I combine those. That's all step 2. I moved my variable term from this side to that side, combining them. Now we've got it on one side of the equation. Next step, which is step 3, says I need to isolate the variable term. Well, notice my variable term, negative 18x, it doesn't need to be isolated. It's already isolated, so step 3 is done. We don't need to do anything. And our final step, step 4, says get the variable by itself or isolate the variable. I do have a negative 18 in front of it. It's multiplying. So to move it, I need to do the opposite, which is to divide by negative 18. And as long as I do that on both sides of the equation, I haven't broken any rules. Negative 18 divided by negative 18 is simply 1x. And again, I'll write that up here. And then on the right side of the equation, I have negative 6 over negative 18. Well, it turns out I can take a negative 6 out of the top and bottom, and when I do that, I end up with a 1 and a 3. And now I have my solution for the multi-step equation. X is equal to 1/3. That is how we solve basic linear equations. Hopefully you've gotten something out of this video, and go ahead and do the classwork exercises and then do the homework for additional practice, and you will hopefully have this worked out so that you can now solve simple linear equations, whether they're 1, 2, or multi-step. Thanks a lot.